let's find limits of some rational expressions in this video. So if we have a limit of rational expressions like this, the first thing you check is the denominator. If it becomes 0 or not, the moment we plug in our limits here. In this case, our x approaches to 0. When x is 0, let's check it out. Our first term becomes 0, second term 0, so our denominator is negative 5. Our denominator is not 0, because when the denominator is 0, then this won't work. It becomes infinity. Now, since our denominator is not 0, then we can evaluate it right away by letting our x approach to 0, or letting our x equals to 0 this time. This is now 0 squared minus 25 over 0 squared minus 4 times 0 minus 5. And our numerator is negative 25. Our denominator is negative 5. So the result is 5. Therefore, the limit of this expression is 5. You can also check it using calculator here. So I already plug in the expression here, or the equation, and then this is the graph. So when x approaches to 0, then our y is 5. So the limit is 5. Let's move to this second problem. Again, at first we need to check our denominator if it will become 0 the moment we plug in our limits here, which is x equals 1, approaches to 1. So when x is 1, first term will become, okay, the 1 squared is 1 times 3 is 3. The second term, negative 4 times 1 is negative 4 and plus 1. If we add it, 3 minus 4 is negative 1 plus 1 is 0. So this won't work. It becomes infinity. Now, let's do something else in this problem. And that is, we factor out the expressions here, our numerator and our denominator. Let's start from the numerator. So using the FOIL method and the trial and error method. Okay, the FOIL method is this one. Now, first term has 7 as coefficient, so the factor of 7 is 7 and 1. 7 times 1. So we have 7x and 1x. That gives us 7x squared, which is the first term. And let's look at the third term first. The factor of 3 is 3 times 1. Now, we've got to be careful here where we put the 3 and where we put the 1. So the FOIL method is like this. This determines the middle term, and this is the inner and the outer of our FOIL. Now, if we put the 3 here, we multiply 3 by 7, becomes 21. So 3 is not here, should be here, and our 1 is here. Now let's multiply it. 3 times 1x is 3x, and then 7x times 1 is 7x. Now our middle term should be negative 4x, and that's possible when our 7 is negative and 3 is positive. Okay, to make our 7 negative, we put the negative here, so that negative 1 times 7x is negative 7x. And positive here, because positive 3x times 1x is positive 3x. And for our third term, we can check it out. Positive 3 times negative 1 is negative 3. So this is the factor of this trinomial. Let's move to the denominator using the trial and error method again of FOIL. So the factor of 3 is 3 times 1. So we have 3x and 1x. And then the factor of 1 is 1 times 1. So let's check the middle term. This is 1 times 1x is 1x. 3 times 1, 3x times 1 is 3x. And we need to come up with negative 4x as the sum that is possible when our 3 is negative and 1 is negative. So that means this is negative here and negative there. And we can check it out. The first term is 3x squared. The middle term is already done, which is negative 4x. And the last term, the third term, is negative 1 times negative 1 is positive 1, which coincide with this. Therefore, this is the factor of our denominator. Now, let's move to our limits. We can now write this into its factor. This is the factor of our numerator. Over the factor of our denominator. So since x only approaches to 1 here, this won't be 0 at the moment. So we can cancel it out. We now have, just copy this one over as x approaches to 1. This time we now approach our x to 1 and evaluate it to our expression here. We now have our numerator is 10, denominator is 2, limit is 5. So the limit of this expression is 5. We can check this using the calculator here. We have 7x squared minus 4x, then minus 3. This is 3x squared minus 4x and plus 5, plus 1. Okay, now our x approaches to 1. When x approaches to 1, our expression is equal to 5 over here. Our y is 5. Now, if you look at it, if we pinpoint exactly this coordinates here, it's difficult, which is difficult. Okay, hold on, let's move it close. It's difficult to hit it. There you go. So you see, our x is 1 and our y is undefined, because from the start, our denominator is 0, so it does not exist at x equals 1. Let's move to this third problem. The first thing we do is to check our denominator. It becomes 0 when we plug in our x equals negative 2. So we have negative 2 square is 4. Negative 2 plus 1 minus 4. Negative 2 plus 1. So it's going to be negative 1. Negative 1 times 4 is negative 4. And this is negative 1 here. Negative 1 times negative 4 is positive 4. So this is 0. So it won't work. So we need to use something else by factoring. So let's factor our numerator here. Okay, the common factors of our numerator is x squared. It's gonna be x squared. X squared plus 5x plus 6. our denominator, the common is x plus 1, and we will left with x squared here in this term, and minus 4. So we can factor this out. This is x for method 6. We can factor as 3 and 2 to give us 5x in the middle term. That's positive here. So plus 3x and plus 2x give us plus 5x. Our denominator, now here we have difference of 2 squares because 4 is 2 squared. And we can factor it out as x minus 4 minus 2 and x plus 2. Okay, so we can write our limits in these factors now. We have limit as x approaches to negative 2. We can express our numerator into factors. Our denominator as well. This time we can cancel out the common factors of our numerator and denominator. So we have now these remaining factors. Let's copy that as well as our denominator. Now nothing to cancel anymore, so we can now evaluate by approaching our x to negative 2. This will now be negative 2 squared, negative 2 plus 3. This is negative 2 plus 1, negative 2 minus 2. Here we have 4 and negative 2 plus 3 is 1. Our denominator, we have negative 1 and negative 4. There's then 4 over, that's positive 4, so our limit is 1. Therefore, the limit of this expression is 1. Okay, this is another rational expression, problem number 5. If we, at first, we need to check about our denominator. If we plug in our x equals 2 here, this will become square root of 4 plus 5 minus 2 plus 1. This is square root of 9 minus 3. Square root of 9 is 3 minus 3 becomes 0. So the value of our expression at x equals 2 does not exist. Now let's find the limit of this expression. What we're going to do is to multiply this by the conjugate of our denominator. Our denominator is square root of x squared plus 5, so just copy that. And then this is negative, so we write positive to get the conjugate. That's 1. The end result, if we multiply this, is the difference of 2 squares. So we do the same to our numerator to make it balance. And this time we can now multiply. For numerator, we have Let's copy it first. Here we have our denominator becomes, okay, if we multiply this term to this term, it will become square, and the square of square root the square root will cancel out. This will become x squared plus 5 minus, multiply the second terms to this one. So this will become squared, x plus 1 squared. We'll simplify it more. By the way, we can factor this out. Let's check if we can factor this. Oh, yes, we can. It's actually x plus 4 and x minus 2. You can check it out. Positive 4 times negative 2 is negative 8. That's positive 4x minus 2x. It gives you plus 2x. Copy this factor. Copy the denominator and then expand this. This will become x squared times negative is negative x squared. This becomes 2x times negative is negative 2x. It become 1 times negative is negative 1. Okay, we'll copy the numerator. Here, this will cancel out. So we will be left with, by the way, this will become 5 minus 1 is 4 minus 2x. We can factor out the 2. Let's make it negative 2. So factor out negative 2 so that we will match it here to the numerator. So this will become negative 2 plus x, or you can write it as negative 2 x minus 2, and it matches now to our numerator actually. Now our denominator now is negative 2 and x minus 2. Here x minus 2 is common to our numerator and denominator. Limit approaches to 2. So we now get rid of this factor here that makes our expression 0. Let's continue. We now copy the remaining factors. Our denominator is now negative 2. Our limit approaches to 2. We can now evaluate this. So here, what is this one? X plus 4. So when x is 2, it gives us 6. This is going to be 4 plus 5 is 9. Square root of 9 is 3. This becomes 3 here. And where this is 2, 2 plus 1 is 3. So 3 plus 3 is 6. All over negative 2. That's 36. Negative 2. So the answer is negative 18. And that's the limit of this expression. Let's make a quick solution of this limit. So as usual, let's check the denominator becomes 0, which is obviously 0 when x is 0. So this expression does not exist at x equals 0. Now the first thing we do is to get rid of that 0, and we're going to multiply our numerator by its conjugate, which is square root of x plus 2 minus square root of 2 minus x. And so as our denominator, this is minus square root of 2 minus x. Okay, we can now write our limit this way. If we multiply this term to this term, it will become square, and the square root will be eliminated. It's going to be x plus 2. And if we multiply this term, because the result of this, by the way, that's plus here, the conjugate is plus. So if we multiply this to this term, the square root will be eliminated, and we have a difference of 2 squares. This is now 2 minus x. Our denominator is now x. Let's copy that factor there, the conjugate there. And then this one, what this becomes to, this will become x plus 2, then minus 2 plus x. So our 2 will cancel out. We have 2x. We're gonna have limit numerator becomes 2x. Copy our denominator. As x approaches to 0. Okay, we can now cancel out our x. It's common to numerator and denominator. This is now 2 over, okay, our denominator now is x plus 2 plus square root of 2 minus x. As x approaches to 0. We can then evaluate this. We have now 2 over square root of our x now is 0 plus 2 minus 0. This becomes 2 over square root of 2 plus square root of 2 for our denominator. This is 2 over, we can add this, becomes 2 square root of 2. 2 is common. This is now 1 over square root of 2. We can rationalize it by multiplying square root of 2 numerator and denominator. So this is now square root of 2, and this is square root of 2 squared, that's 2. So this is the limit of this expression. This fourth problem is not a rational expression, but I will want to include this one. Now, if we check it, our denominator here won't be 0, so we can evaluate right away our x when it approaches to negative 3. So this is going to be negative 3 plus 1 plus 3 over negative 3. It's going to be negative 2 here plus, and this 1 becomes negative 1. Absolute value of negative 2 is just 2. Absolute value is only the positive value. And then positive times negative, that's negative 1. So 2 minus 1 is 1. So the limit of this expression here is 1. We can check it using our calculator. Here, when x approaches to -3, this one, our y is 1. Okay. Alright, if you have a limit of this type where x approaches to infinity, then the trick here is to factor out the greatest exponents of our x. It's gonna be limit. Now the greatest is x squared. The greatest degree is square. So we have, I'll show you first. Factor out x squared here. This will become 2 plus 1 over x squared. You can return it. That's 2x squared, then plus 1. Here you factor the same thing, x squared, and this now becomes 1 over x plus 5 over x squared. Okay, as x approaches to infinity. You can return it, gives you x, gives you 5. Now we can cancel this out since our x is not yet infinity this time. Now let's approach our x to positive infinity already by having this factor, remaining factor. We then have 1 over infinity is 0 plus 5 over infinity squared is just infinity, so that's 0. And here 2 plus 1 over square infinity gives you 0. So 0 over 2, the limit is 0 of this function.